Hello everyone. Our presentation is titled Who Will Speak Up in Class? This mini project explores whether we can use machine learning to predict which students are more likely to actively participate in class discussions. Over the next few minutes, I, Ishita Bose, along with my teammates Onkona Bhaur and Tanisha Singh, will walk you through our research question, the data we collected, how we built our models, and the key insights we discovered. Our central question is, can we predict which students will actively participate in class discussions based on their personal characteristics and interests? To study this, we define the target variable as introversion versus extraversion, where 0 represents introvert and 1 represents extrovert. The key features we examined include number of books a student reads annually, a risk-taking behavioral score, and the type of club a student is most involved in, such as sports, cultural, or academic. We worked with the assumption that personal habits and club activities can serve as reliable indicators of classroom participation tendencies. Now, to explore how we prepared and processed our dataset, I'll hand it over to Onkona.
So the next slide is data preprocessing and feature engineering. To prepare the data, we first handled missing values using median imputation for numerical features and mode imputation for categorical ones. Next, we performed categorical encoding, applying one hot encoding to the top club type so that sports, cultural, and academic clubs each became their own indicator variable. For feature scaling, we normalized the number of books read and the risk taking score using a standard scaler to ensure every feature contributed equally. Finally, we carried out feature engineering by creating interaction terms and club specific dummy variables to better capture subtle behavioral patterns. Next slide is model selection and implementation. With the cleaned dataset ready, we tested three different models. Number one, logistic regression served as our baseline because it offers interpretable coefficients and probability estimates. Number two, random forest classifier allowed us to capture more complex non-linear relationships and also gave us feature importance rankings. Number three, support vector machine, a kernel-based classifier, worked well for clear decision boundaries on smaller datasets. All models were implemented in SkyKite Learn pipelines and evaluated using a 70-30 train test split for reliable validation. Having built and tested three models, the next step was to evaluate their performance and see which one worked best. For that, I'll now hand it over to Tanisha Singh, who will walk you through the results and insights we gained.
After training the random forest model achieving the best result with an accuracy of 87%, our F1 score was 0.84, showing a strong balance between precision and recall when predicting extroverted participation. The support vector machine followed with 82% accuracy, while logistic regression provide a solid interpretable baseline at 79%. Overall, the random forest proved most effective at capturing complex interaction between student characteristics and participation behavior. Now, next slide. From this result, we draw three insight. Club activity impact. Student involved in sports and culture show a 2.5 times higher likelihood of active class participation. Risk-taking correlation and higher risk-taking scores strongly correlate with extrovert classroom behavior and frequent question asking. Reading habit patterns. Students who read a lot but aren't active in club lean toward the introvert participation types. Based on these findings, we recommend that faculties encourage introvert students to join club or group activities, create structured speaking opportunity for avid readers, and leverage high risk taker as a decision facilitators. These steps can help in increasing overall engagement and make classroom discussion more dynamic.
Thank you, Tanisha. With that, we come to the conclusion of our project. Our project shows that student habits, interests, and personality traits can be strong predictors of classroom participation. By applying machine learning to this problem, we gained not only predictive power but also practical insights that educators can use to create more inclusive and engaging learning environment. That brings us to the end of our presentation. Thank you.